There we go. So it's there now. I just put it on LinkedIn community so that those people who are actually joining us from LinkedIn. So now we are going to start about today's webinar, which we talked about last time. And you know that we committed about commissioning, electrical and automation commissioning webinar. Mainly, we would be focusing on automation commissioning. And we have one of the experts from Canada. His name is Paul Turner. He have a vast experience in commissioning, and he have launched few amazing courses in domain of electrical commissioning, mechanical commissioning, and today he would be talking about automation commissioning. And those guys who would be part of that live webinar, you need to just put a comment down there, and also you have to follow the steps that are written into description of the video. And you have to follow the Instagram, and also you have to register on the link that is provided. All those folks who were, part of that live webinar for full time would, like you started with at the beginning and at the end, you finish it up, you would be able to get a certificate, and that certificate would be presented from Paul's organization and IT and Automation Academy's YouTube channel. Now I'm giving my rights to talk about electrical commissioning and automation to Paul. Thank you very much, Paul, for joining in. Over to you.
Thanks, Naman. I'll just pull up my screen here and hopefully get the screen sharing going. So let me know if you can see the presentation here. So for today's discussion, I'll go through a little bit of my commissioning experience. We'll talk about commissioning of automation systems. I've also got some really good bonuses and goodies for everyone at the end of this webinar. Please stick around to the end. I'll tell you how you can access some of those resources and learn more about commissioning. And then we'll have a live Q&A at the end of the session here. So a little bit about me. My name is Paul Turner. I'm a professional electrical engineer and a registered project management professional. I've been working on complex systems for over 20 years, and through that time I've gained some valuable experience commissioning complex systems, and I'm happy to share that knowledge with you. I'm located in Canada. We're in central Canada, right in the middle between Toronto and Vancouver. I have an awesome family, and we love to explore the outdoors in Canada. So some of the earlier projects that I've worked on were in the aerospace industry. This is a picture of me looking through the Cassiope satellite. It was launched in 2010, and it has a suite of 8 science instruments that measure the magnetics of the North and South Pole. Also worked on a smaller satellite system for the Canadian Space Agency, that is SciSat there. It measures ozone levels in the atmosphere through occultation of the sun as it sets and rises 15 times a day. More recently, I've been working in the power generation industry and the power transmission industry. A few years ago, I built a 200 megawatt hydroelectric generating station in northern Manitoba. I was the commissioning manager for a 2300 megawatt HVDC link from northern Manitoba to southern Manitoba, and that was a $5.2 billion project that we delivered on time and on budget. And currently, I'm the commissioning manager for a wastewater treatment plant where we're upgrading and expanding the existing facilities. So the topic of discussion that we're here for today is commissioning of automation systems. And when we think about commissioning, commissioning really spans the entire duration of the project. So you really need to start with the end in mind at the beginning of the project, thinking about commissioning and how everything is going to come together in the end to plan that successful commissioning. So the two things to start with for definition of the automation systems are the process control narrative and the functional requirement specification. These are really the part of the technical specification related to automation, defining how the automation systems are to function. So The PCN and the FRS will be prepared in advance. The programmers will use those documents to know how to program the systems. And then ultimately, those are the important documents to the commissioning team to know how the systems are to function in the end, therefore, what needs to be tested to prove that the systems meet the technical specification. So these are two very important documents for the commissioning team to relate to for automation. So some of the terms that you'll see in testing of automation system is your central control room. So that's the one single location where all of the SCADA PLC DCS systems can be controlled from. That would be the one location where all the HMI screens are located and the operators can access the systems from that central location. PLC, of course, is the programmable logic controller, the actual hardware in the field that is programmed to control the plant process systems. DCS, the distributed control system, would be all the PLCs, all the interconnections, the overall entire distributed system that controls the plant process. HMI, the human machine interface, those are the HMI screens in the control room that the operators interface with for monitoring and controlling the systems. The alarm screens, that's a very important portion of the HMI system that the commissioning team will want to pay attention to. The alarm screen is really all the statuses from the system, and as you're going through and commissioning the systems, the alarm screen is probably the first thing that you're going to be paying attention to confirm that you're getting the right responses from the end devices and they're alarming at the right levels for high or high alarm points. The alarm screen is something definitely to pay close attention to during commissioning, because that's really the operator's main alerting portion of the HMI system to know if there's components within the plant that need to be addressed. And it needs to be accurate. If there's a whole bunch of spurious alarms that are coming in on the alarm screen, that's not going to help the operators trying to troubleshoot all these alarms if they're not real alarms. So in the end, through the process of commissioning, we definitely want to make sure that the alarm screen is proper and clean and makes sense to the operator. I'll mention BMS. That's maybe a subset of the HMI system. BMS is specific to the building management system, and I've seen it exist separate from the rest of the plant process. I've also seen it integrated as part of the plant process. It may just depend on how your contract is specified and how the building management systems are incorporated into the overall SCADA system. So with regards to getting ready for some of the commissioning tests, some terms you might hear is a SIFT, a system integration functional test. Now this is the simulation aspects that are completed on a test bench prior to getting to testing in the field. Factory acceptance test, and we'll go through this one a bit more in a few slides, is very important to the commissioning phase. The factory acceptance test, and it really should be an integrated factory acceptance test, is confirming that the hardware and the software function correctly before any of the systems even arrive at site. The site acceptance test is confirmation that the hardware, once arrived at site, is installed correctly, all the cables are pulled, terminated correctly, and that end devices are installed correctly. So that site acceptance test would be one of the pre-tests to confirm prior to moving into commissioning. And then the site integration test is when the software is actually programmed into the hardware and the two can function on site. So let's go through some of the steps to get ready for commissioning. In advance, during the design phase, once the software is written, you definitely want to go through a simulation process to confirm that what's programmed is actually going to function by the time it gets into the hardware. So through simulation on a test bench, what the test bench could be a set of replica hardware, a replica PLC to kind of replicate the hardware. With the software programmed in there, you go through all the process control functions, all the complex logic, and you confirm generally that the software is going to function correctly before it gets into the field. This is important even in advance of factory acceptance testing, because when you're testing on that test bench, you're going to troubleshoot all of the errors that exist in the software and get it ready for functional testing as part of the actual hardware. Now, when you get to factory acceptance testing, I can't stress enough how important this is as part of the commissioning phase. Lots of people might think that this is an earlier activity that precedes commissioning, as maybe handled by the design team, and the commissioning team doesn't need to get involved, but that's not true. This is definitely a critical step of the commissioning process. And the focus needs to be on the hardware and the software. The factory acceptance testing can't be just a verification of the hardware. It needs to also incorporate the code that has been simulated to prove that both the hardware and the software function correctly. Doing this earlier in the project and proving the software at this point in time is immensely valuable to the commissioning phase later. I've seen this done in two different ways. I've seen it done where the factory acceptance testing is properly planned, software is available, and many months of testing has taken place, upwards of like 6 months. Now, that has been thoroughly beneficial to know that at the end of that factory acceptance test, your hardware and your software are going to work properly together. I've also seen this done the other way, where the software is not ready, it's only half written, you only kind of partially go through verification of the software, and there's always pressure to ship the hardware to site, and someone decides, okay, good enough for factory acceptance test. After 2 or 3 days, we're shipping the hardware to site. That causes nothing but problems. Once your hardware arrives at site and it's installed, that's all great, but your software still hasn't been proven to work, and it's delayed much later in the process. But by the time all your hardware is shipped, and by the time you've got software that's ready to be tested, that's much later in the process, later in the project, that you're really completing your software design as you're trying to do commissioning. And that never goes well. I've seen that cause nothing but problems, and I strongly discourage that. Having a properly planned upfront factory acceptance test where you test both the hardware and the software will always save the project several cost and schedule impacts. And I need to stress the importance of doing an integrated factory acceptance test. So again, to stress that commissioning spans the length of the project, the factory acceptance test being a very important part of that sequence. And upfront, the project leaders need to plan the proper integration of the hardware and software during the FAT. That means that the software design is going to have to be ready a lot earlier, but it mitigates many possible impacts of cost and schedule by planning out your project that way. So another important aspect is for the commissioning team to define the construction priorities that are needed in order to integrate the hardware and the software on site. So this includes all the placement of cubicles in the various plant processes. And when you're working with such an integrated system like this, with all the cubicles placed throughout the plant, all the cables that need to be pulled, and all the end devices that get interconnected to the system, it definitely needs to be very planned out. In a lot of cases, it can be segregated, where maybe a certain plant area is required before the next plant area, and you need to plan out the isolations between a portion of the SCADA system versus another plant area that doesn't necessarily need to be implemented that earlier in the project, but still needs to be isolated from the current systems that are under test. So planning this out with the construction team is critically important to determine which areas of the SCADA system are required, which are not required until later, and the construction sequence of how this is all going to come together in order that the commissioning team can build up a proper plant process. Once you get through construction, really the focus, because the hardware and the software were tested extensively during FAT, it's really the installation that you're going to be verifying on site. And that's largely consisting of all the cables that have been pulled to interconnect all the systems. So one thing that's very important as part of the construction phase is to do all the proper point-to-point checks and all the mega checks of all the cables that have been pulled to confirm that it's been installed per drawings and that all the cubicles are interconnected as they need to be. As a commissioning team, we certainly want to be testing the actual functionality of the plant systems. We don't necessarily want to be troubleshooting all the wiring errors and items like that. Of course, there's always wiring errors that pop up, and the odd one isn't a big deal. If you got a rolled wire and you need to flip it, that's not that big a deal. But if the commissioning team instead is spending their time troubleshooting multitudes of cable errors, then that's not entirely productive. So that does need to be a proper upfront process defined in construction ITPs to do all the point-to-point and mega checks of all the cables. Once that's complete, then we move into mechanical completion. So mechanical completion is when each system is handed over from the commissioning team, from the construction team to the commissioning team. So the commissioning team will work with the construction team to define the various mechanical completions that are required on the project. So like I talked about earlier, one of the plant process areas may be required in advance of another plant process area. You would define a mechanical completion for that portion of the system for that plant area, itemizing everything in that mechanical completion that needs to be completed for that plant area. You'll have a series of mechanical completions and definition between the construction team and the commissioning team on what's required and when each is required. An important thing to include in each mechanical completion is a definition of the documentation that is required for your system. So some important aspects are all of your red line drawings. The commissioning team definitely needs to understand the as-built configuration in the field. So if there was design changes or installation changes, those need to be reflected in your red line drawings that the construction team hands over to the commissioning team at each mechanical completion. Invariably, there's likely going to be a series of mechanical completions where one portion of your system is going to be under test, while another portion of the system is still being built. And this needs to be very closely managed, especially when it comes to automation systems, because all of these systems are interconnected. There could be wetting voltages going from one cubicle to the next. And a definition of what systems are under test versus which ones are still being constructed needs to be formally defined in your lockout tagout procedures, your permit to work procedures, so that all boundary isolations are clearly defined and everybody knows what area of the plant they can be working in. You certainly don't want to have one system that's under test while another group is still working on that same system. That can present significant electrical hazards that need to be mitigated so that everyone is safe and can complete the work safely. So following mechanical completion, we move into pre-commissioning. And again, since the FAT was conducted very thoroughly, pre-commissioning will largely consist of verifying that there are no installation errors. Through pre-commissioning, this is really when the loop checks will be completed. So through the loop checks, you'll be verifying from the cubicle, the cabling is correct, that you can communicate with the end device, that you're getting the right control and monitoring of that end device. You're getting the right response from the end device back to the PLC. All of the alarming and interlocking interfaces, everything's verified during pre-commissioning, during loop checking, to ensure that all of the information that you're getting on your HMI screens is correct and that you can access all the devices within the field. So once that's confirmed, once you can confirm that everything's interconnected correctly and all loop checks are completed, any additional electrical pre-commissioning is completed, such as high pot testing, or if you're working with large rotating machines, maybe short circuit or open circuit tests. we can move into the commissioning phase. So this is the testing that would take place prior to starting the plant. This would be verification of the detailed or complex process logic functions in the field. So this is really where we start getting into some of the tests that were completed in the FAT are now completed in the field to confirm that the logic functions with the end devices actually installed now are functioning correctly per the PCN and the FRS. So what this would mean, for example, is say you've got a level sensor in a tank. When you get to that high level sensor input and that device is triggered, maybe the next logic function is to turn on a pump. You want to see that that pump actually turns on as controlled by your logic. Maybe you want to then get to the next higher level sensor in the tank for the high. Maybe at that point it kicks in another pump. You want to see that that second pump is going to run. Now, because this is without the plant fluids in there, your tank is likely dry and has no liquid in it. So through some of this, you may be stimulating the level sensor. It could be various different methods. It could be something even as simple as a piece of cardboard on the end of a stick to confirm that you're triggering the level sensors, to then see the high and then see the high level trigger and watch the process logic function correctly to turn on a single pump, turn on the next pump, and ensure that your system reacts accordingly. Through these testing of the logic functions, you're going to want to test all of the normal operating conditions, but you're likely going to want to test all the fault scenarios as well. And you'll have to determine a method on how you're going to trigger some of these fault methods in order to test the logic. So as another example, maybe you've got a pair of pumps, a pair of redundant pumps, and with one pump running, you want to fail that one pump and ensure that the logic switches over and turns on the other pump. You're going to want to go through all of those scenarios as well to test each of the fault scenarios. This automation commissioning, depending on the complexity of your system, can take days, can take weeks, can take months. On the last project that I've worked on $5.2 billion HVDC project, we were going through automation commissioning for close to a year to test out all the stability controls, all of the normal operating conditions, all of the fault conditions, go through all of the electrical equipment to confirm that everything is functioning as an HVDC system. Now, that system was even more complicated because with an HVDC system, you have two control systems, one at each end of the 1,400 kilometer HVDC line. So going through that complex logic of two stations that are interconnected 1,400 kilometers apart was a bit of a complex process, but certainly lots of fun. So once we've gone through and proved that the complex processes function correctly on site, we're now ready to actually start up the plant process. So in the case of a mechanical system, that may be for the first time introducing some of the plant process fluids to the system, introducing chemicals to the system, whatever the mechanical process consists of. In the case of an electrical system, that may be starting some of the electrical power transfers. You would ramp those up at certain levels. Maybe you'd go from 25%, 50%, 75, 100 as you'd slowly start up the plant processes. Starting it up in stages, of course, to confirm that your system is still functioning correctly at each level before moving to the next one. Now, this is with everything in place, all of the interfaces and all of the external, internal controls, everything acting as a system. One thing I'd also like to point out through commissioning is that the commissioning team definitely plays a large role in operational readiness. So for operational readiness, this is ensuring that the operating team, the owner's operating team, is ready to operate and maintain the new plant facilities. And the commissioning team can definitely help with this. One of the best ways is to actually have the operators participate in the commissioning process, have them embedded right as part of the commissioning team. This is a fantastic way for operators to understand the systems, get hands-on experience troubleshooting the systems, ask any questions of the experts that are on site, and really get a good understanding of how the systems are to function and how to interact with them. But there's other aspects of operational readiness as well. Certainly, operators will go through training. They'll need a whole suite of documentation to operate the new facilities, as well as all their asset management systems, particularly for automation systems. If operators are expected to be interrogating or making changes to the system once the warranty is complete, the commissioning team can definitely help get operators prepared to be able to do some of these tasks. So when it comes to the automation system, some of the documentation and specialized tooling or program equipment is important to consider because when you're interfacing with the existing or the industry standard PLC systems that are out there, there's usually some special documentation and programming tools required in order to do that. And certainly some expertise that's required to not just have anybody poking around in your logic systems and making changes. So that's something definitely to get the operating team up to speed with. An aspect to also consider is whether or not your system is defined to be cyber secure. Now, this is no small task to become a cyber secure system. On our last HVDC project, we were required to be NERC CIP compliant, and that was a huge undertaking to obtain that compliance, and then just as equally a huge activity to maintain compliance at in-service date. Cybersecurity could be a whole topic that we could spend another whole session on. You can check on my YouTube channel. We have had some webinars in the past where we've gone through the details of cybersecurity, and I encourage you to check those out to see what's required as related to defining your system as cyber secure. So that's a bit of an overview of commissioning process from an automation perspective. I did promise you some bonuses at the beginning of this session, so let's go through those right now. So what you'll get is a certificate of participation for participating in this webinar. At this link below, you'll also get a copy of the slides. And because Engineer Noman has been so gracious in allowing us to participate in this webinar, for the next week, I'm also going to offer a 15% discount code on our EIC accredited commissioning training. So if you check out our site, we offer training programs for commissioning that are accredited by the Engineering Institute of Canada. This is a highly sought after accreditation, and we're pleased to offer training in mechanical and electrical commissioning. So please sign up for these bonuses at this link below. You can go to commissioningandstartup.com/ITAA, and at that link, enter your name and email, and we'll send you all of these bonuses. Now, the link, the discount code for the 15% discount code is only available for this week. If you're watching this webinar past December 6th, no problem. You can still access this link. You'll still get access to the certificate of participation as well as a copy of the slides. So please go to commissioningandstartup.com/ITAA to get access to the bonuses from this webinar. So with that, Noman, I'll turn it back to you, and we can go through any questions that you may have or the audience may have.
Yes, for sure. We would be definitely talking about that. And first of all, really happy to see the response from everybody who joined this live webinar. And I see many people are asking about the certificate. And most of the people are saying that they are facing the issue of certificate. Don't worry, there is a step-by-step process written here into description of the video. You can get into that. If you guys face any issue, I'm giving you one email address. That is my direct email address. You can write me if you face any issues. My email address is noman@onlineplc.org. And now I head over back to Paul. Paul is having a very vast experience in commissioning. This is just the first section of our continuous effort. We had a very good session on Paul's YouTube channel. He's running a very nice YouTube channel. He just recently started, but the amazing work he's putting up already, that's really showing the skill set he have, or the experience he have in the domain of commissioning especially. So I would be updating the YouTube address of Paul's YouTube channel. You would be able to access, and if you want to see commissioning related videos, you would be definitely will be able to get that. Apart from it, Paul, if you want to give your Instagram ID that people want to talk to you, you can also share.
Absolutely, yeah. You can check out all the social channels that we have at commissioningandstartup.com. And by going to that link, commissioningandstartup.com/ITAA, we'll send you all the information that you can link up with us, our YouTube channel, all of our social profiles on LinkedIn as well. So please go to that link, commissioningandstartup.com/ITAA, and you'll learn everything about commissioning and startup and how to get in touch with us.
Now, thank you very much, Paul. I'm getting a lot of questions, and all those folks who are, finding a difficulty in registration, again, I'm saying you can reach me on my WhatsApp number. That's also provided into online training announcement video, and I would try to update it here. Either you can write on Instagram if you face any issue. The best way is definitely all those folks who are part of this live, they would be only able to get that definitely a certificate. So you need to have a kind of a proof for that also, that you are here. So I know people who were participating here. So please write your questions so that I don't forget you to issue a certificate. Apart from it, there is an Instagram ID that's already on description of this video. Those folks who find it difficult to reach me on email, they can also reach me on Instagram. And all those folks who follow Instagram and they register the link that is provided here into the description of the video, that would be working now. So you just need to click it out and you need to fill in the details. You would be able to get a certificate for sure. Now is the time to ask the questions. So please write your questions. Any question you want to ask to Paul, it's the right time to address that questions. So please, anyone. I'm looking into the questions now. Let me get back to a few things here. Okay, sir, please explain SCADA in short. Paul, over to you.
SCADA in short, the term SCADA, the term DCS are very similar. Really what that refers to as the overall architecture of how all the systems are interconnected and how all of the information throughout the plant process is gathered, monitored, and controlled and brought back to the central control room for interface and control. Think of SCADA and DCS, the distributed control system, as containing the entire plant, all the cubicles, all the cables, all the end devices, how the physical hardware of everything is interconnected. Within that, there would then be a PLC or an RTU that would be reference to the specific hardware that makes up the DCS or SCADA. But SCADA refers to the overall architecture of the system.
Perfect. So we got another question from Walid. He's saying that what is the fee structure of the course online?
So we offer two different options there at that link, commissioningandstartup.com/ITAA. All those resources there are free. So you get access to the certificate for free, a copy of the slides for free, and the discount code, you can get access to that as well. Now we offer a free 3-day mini course. It's free to sign up for, and you can sign up for it at that link as well. The 3 free-day mini course gets you set up with everything you need to get started with for commissioning and startup. If you sign up to that course, then over 3 days, we'll send you the course material, all the resource downloads with videos included as well. Following that, if you're interested in more in-depth training on mechanical and electrical systems, we offer our 2 Engineering Institute of Canada accredited training programs on each of those for mechanical and electrical. And the fee structure is shown on our website there. The mechanical course is $247 US. The electrical course is $297 US. But with the discount code that you get at commissioningandstartup.com/ITAA, you're able to save 15% off both of those courses within the next week before December 6th.
Okay. Now I'll get a question from Tayyib. He's saying that what's the difference between PLC and DCS system? Yep, Paul, please.
Sure, for sure. So the PLC is the actual piece of hardware out in the field. So picture a cubicle, electrical rack, and it's got a bunch of equipment that's in there. Say it's like a server rack or a communication rack. One of the items that you could have in there is your PLC. That's the actual piece of hardware that then has all the cables coming in and out of it and is programmed with the software to actually implement the plant process that you're looking to implement. The DCS then refers to everything within that plant process. So you could have 100 different cubicles, you could have 100 different PLCs that are distributed in various points of your plant. The DCS refers to that distributed control system of interfacing all the cubicles all over the plant, how that information is gathered, and how it's brought back to your control room for display on the HMI screens.
Okay, we got a question from Kumar. He's saying in order to be a commissioning engineer, we need to learn cybersecurity. Is it necessary?
So that's going to depend on the definition of your system. Cybersecurity seems to be becoming more and more relevant in today's world. I can recall it was like over a decade. It was a while ago in the eastern seaboard of the United States when there was a widespread tens of millions of people that had a blackout situation for a good period of time. That event has really spurred the need for cybersecurity and security amongst interconnected systems when we see outage events like that occurring. Since then, cybersecurity has become even more important in a lot of the systems that we work on. So while not all systems are deemed to be cyber secure systems, it certainly does seem to be more relevant in today's world as new systems are brought online. And I can only imagine as more PLC systems, SCADA systems are implemented in some of our critical plant infrastructure for our wastewater treatment plants or power delivery systems or things such as that, that cybersecurity is only going to become even more and more important. Now, that's not to say that it's an absolute requirement to become a commissioning engineer, because there's still lots of systems that aren't cyber compliant and don't have those requirements, but it does seem to be something that's more and more important these days.
So we got another question about the job opportunities for instrumentation engineers.
Instrumentation engineers are definitely in demand for teleprotection, for communication, for all those specialty disciplines that are required on the commissioning team. Lots of people ask me, do you need to be an engineer to be part of commissioning? And the answer is no. Some of the best people that I've worked on had on my commissioning teams have not been engineers at all. There's all sorts of specialty skills that are required on the commissioning team. And the ones that you mentioned there for instrumentation techs are definitely ones, skill sets that are highly desired on the commissioning team for all of our protection and control systems. That critical expertise of how those systems work, how everything interfaces, there's definitely a demand for in the workforce for instrumentation and engineers, instrumentation techs. So if that's something you're interested in, I would strongly encourage you to follow that and learn those skills further to become part of the commissioning team and add your knowledge to the experience.
Well, Kos Bashir is saying that great stuff and effort for bringing in. And I would be interested to learn about industrial cybersecurity related courses. And would you like to offer the same?
So as part of our electrical commissioning course, that is a module that's required, is included in our course is cybersecurity. I definitely appreciate your interest in cybersecurity. Maybe what you're suggesting is a dedicated webinar specific to cybersecurity and commissioning of cybersecurity systems. That's certainly something we could collaborate on in the future, Naman.
For sure, that's a really nice thing that's in plan. So we would be for sure bringing in one more session, either on your YouTube channel or here. All those folks who are actually here, I request you guys to please have look at the Paul's channel also. We would be getting into every comment here. So please, you need to write comment here. Any question you have, we would be definitely addressing every question here. So next question is from Tayyib again. He's saying, I learned PLC in HMI, SCADA. Can I get a job in robotics field?
Related to commissioning, I would think so, yeah. Commissioning could apply to any of the plant processes. So in my mind, I have some of the pictures you see on TV of Tesla building cars using a lot of their robotics down the assembly line. And certainly programming PLCs, HMIs are definitely aspects there that the commissioning team would verify before putting a plant process such as a automobile assembly line in service. So for sure.
So we got a new question from Yusuf Ahmed, and he's saying that I'm going to start a career as an electrical design engineer. Will PLC, DCS, SCADA is useful in my career growth?
Absolutely, yeah. As part of any engineering discipline, I find it hugely beneficial, even unrelated to commissioning, that everyone kind of have that understanding of how this all fits together, how all the systems are interconnected, and how it's going to work in the end. In cases where I've seen very specialized engineering, where they only focus on maybe their portion of expertise, but don't understand how everything is interconnected and controlled in a SCADA system, I see that as somewhat as a disadvantage. So I definitely think, even if it's not your specialty, that there needs to be an awareness of SCADA systems to know how this is all going to fit together and function as a plant process in the end. And even just having that knowledge and understanding how your piece of the puzzle is going to fit together is hugely beneficial to anyone working on projects like this.
So we got another question from Kumar. He's saying that required skills for graduation to begin as a commissioning engineer.
So the best thing I can recommend is to get that upfront learning, get that solid knowledge base of commissioning before going to site. Commissioning really requires years and years of experience. We want to have that commissioning engineer on the team that's got 30, 40 years of experience, has done energization of that particular piece of equipment 100 times because they've seen it all before. They know what the possible issues could be, what to look out for, and advise the team on being prepared for those energizations. But there's a huge range of skill sets that are required on the commissioning team. To get to that decades of knowledge obviously takes some time, but to advance your knowledge and accelerate that learning process, the best thing you can do is take a course. You get all the terminology, all of the fundamentals understood, so that when you get to site to continue that learning process, you've skipped so far ahead and have all that knowledge that maybe has taken other people years to gather and understand. So that's really what I'm hoping to provide here. Is I've done that. I've gone through my 20 years. I understand all this stuff, and I'm offering this knowledge to you to rapidly learn it and understand the fundamentals of commissioning so that you can accelerate your career as well.
So we got a very good question. He's asking about standards that are important for commissioning engineer. What are the important standards? Somebody who is interested, what he should start, from where he start learning, and which standard he should look into.
So when it comes to standards or like certifications in commissioning, there are certifications that exist particular to building commissioning. Some of the building commissioning certifications like NEBV would provide certification for building commissionings. But what I find is that when you get to that next level of complexity and you're looking at SCADA systems and interconnected architecture, that's completely different than building commissioning. Building commissioning would be one subset of commissioning. Obviously, we need the building to have heating and cooling and fire alarm systems, security systems, all that stuff. But that's really the upfront shell of the building in order to then get to the actual commissioning of the plant process. And when it comes to certifications for process commissioning, I haven't found much that exists online or in the world. There's not really that one certification for process commissioning. So while you could proceed certification on building commissioning, I haven't found a good resource for process commissioning. And that's what I'm creating here, is that next level of commissioning expertise to focus on commissioning of more of the process systems.
So we got another question. Please explain how to DCS system use in process system and how it is important.
For sure. So let's maybe use an example of a wastewater treatment plant. And there's several buildings that span all over a huge location of the property. In each of the plant areas, there's 2 or 3 cubicles that include the actual PLC. Those distributed cubicles are scattered everywhere throughout the plant. So what the DCS refers to is the collection of all of those PLC cubicles all over the plant and gathering that information and bringing it back to that central location to monitor and control the distributed network that's throughout the wastewater treatment plant. In that central control location, the operators are interacting with an HMI screen where they can visually see the plant process, and they can monitor the status of it and then control different aspects of it from one central location. You can see how the DCS makes operation of a distributed system much easier. If the poor operator had to run all over the plant to flip switches all over the place, that would take them forever and not provide much of a real-time control of the system. But with implementing a distributed control system, we can gather that data, bring it to a central location, have a single operator look at the information, make decisions on it, and provide signals back out to other distributed PLC racks in the plant and control the system from one location. So that's what the DCS refers to, is this gathering and controlling of data over a large area or space within a plant or even remotely off-site to help the operator manage and control a plant process.
Very good. So there's another question from David. He's saying that I would like to see some dedicated power plant and distribution training.
So this is a good point, because this is lessons that we do have in our electrical commissioning course. So not only do you get to learn the entire electrical commissioning process from start to finish, but we also offer lessons that are specific to a few different electrical systems. So within there's distribution training on electrical distribution in a small facility. We do have hydraulic turbine and generator training, wind turbine and generator training. And what each of these lessons includes is an overview of the plant process and an overview of how to start up each of these processes. But more importantly, we include all of the templates that are required for commissioning a power plant or commissioning a distribution system. Each of those plans, procedures, and checklists, there's over 90 of them that are included in our electrical commissioning course are a huge resource that you can use as templates when you're creating your checklists and procedures for your commissioning projects. It's a great starting point to at least have a document to start with that you can modify specific to your project.
Before we go to the next question, everybody who's watching this live, first of all, really thankful to everyone. We would definitely address everybody's question here. So you please write your question, make your mind clear what you want to ask, because it's the right time. Paul is a very busy person. He has set some dedicated time for us. And we really want, as IT and Automation Academy's YouTube channel, first of all, we want to honor Paul for to be here, because getting a time from Paul is really valuable and good experience. And inshallah, we would be continuing this kind of activities. We would be definitely bringing back Paul. But for sure here, those who are just worried about the certificate, please don't worry, don't panic. You can reach to my Instagram. You can reach to, there is a link into description of the video. You have to register there. You would definitely get a certificate, but you have to follow Instagram, and Instagram information is also provided there. And if you face any difficulty, you can also reach me on my WhatsApp. I would update the WhatsApp information right after this end of this live session. Now, getting back to your questions, and what's the next question? What is the difference between commissioning engineer and automation system engineer?
So an automation system engineer would be one particular portion of commissioning within the commissioning discipline. If you're referring to automation system engineer, that could be also the designer of the automation system. You can have an automation commissioning engineer as well, which would be a specialty subset within the commissioning discipline. The commissioning engineer may be responsible for commissioning of the automation system, but could also be responsible for commissioning of the electrical systems and the mechanical systems as well. But certainly within that commissioning engineer role, you can specialize in commissioning of specific systems, and that's definitely required. Not just anybody can commission an automation system. If that's the path of expertise that you've pursued, then you can go through automation commissioning process as well.
So we got a very good question. What is the scope of mechatronics engineer for automation field?
So that would be a mechanical, maybe more so a joint of mechanical, electrical commissioning in the field. When you're integrating all three of those, the mechanical, electrical, and automation, that could refer to mechatronics. I'm thinking again of the Tesla automobile assembly line, where you see the pictures or the videos online of the large machines that are grabbing large pieces of equipment and inserting them into the vehicle assembly line. That would be mechatronics, but as part of that, there's the mechanical movement of the robotic equipment. There's the electrical interface to power and signals coming and going from the equipment to the various aspects of the assembly line. And then, of course, the automation that controls that process, so that as the assembly line is moving along, the mechanical systems are inserting the parts that they're required to insert. So mechatronics engineer would refer to the integration of all three of those aspects, so that you have a mechanical robotic controlled system.
So next question is, I think, towards me, because it's about control system. I'm a tender engineer at Schneider in process automation field, working on DCS and SIS system. Is this useful to me? Any advanced technical courses you recommend to me? First of all, Paul, I want you to address this question from your end, because I think I got this query also on my WhatsApp number also. Then I will take on this question also, please.
Yes, so a tender engineer for sure. When I talked about the commissioning being the end-to-end process, really in the upfront processes where contracts are being reviewed and awarded through that tender process, that's really the first step there that's going to set the commissioning team up for success. When you're looking at tendering equipment, and how that all fits together through the design, that's critically important. When you're looking at the larger procurement, say of awarding contracts to the engineering firm or the contractor as well, those tendering skills, those contract skills are critically important. I have gone through some recent webinars where we've talked about contracts as related to commissioning, because as a commissioning engineer, you definitely need to understand the contracts and work within the bounds of the contracts. The commissioning team may pay particular attention to the technical specification, but we definitely need to be aware of the overall contract and commissioning's role within the bounds of the contract. So to answer your question, I do think that tendering skill set is certainly useful.
Yeah, so very good answer. And just want to add, we are also offering few courses on same domain on PLC, DCS, and SCADA, HMI. And these courses already, we have many folks who are learning from all across the globe. And we have a very good dedicated team. I myself also training online. And the beauty of our training is we are making the sessions based one-to-one live sessions. It is not going to be some sort of, where you will not be able to ask the question. So all those guys who are interested, please, you can also reach me on my WhatsApp. There will be few slots opening up very soon again. And on first call, I got a huge response. Even I was not able to take care of everybody. So to answer to your questions, understanding PLC, DCS, SCADA system is really very vital for a tender engineer to understand the whole process very well. So that's my go on that. And getting into the next question, for Paul, first of all, before moving on to any other question, I would like to ask you one question. How much time you have, because we see people are still there. They are happy to listen you more. Please let me know about your timing schedule for today's morning.
I'm all good. As long as there's questions coming in, I'm happy to answer them.
Perfect. So guys, you need to put up your question if you haven't yet, because we got a huge list of the question already. So would be answering one by one. How long on average does a commissioning engineer stay away from home? Very good question.
Very good question. Yeah, I can certainly understand that commissioning can sometimes be challenging. It's due to some of the travel requirements. These big infrastructure projects, they don't always exist in your backyard, right? So sometimes there's some travel required. On the last project that I worked on, an HVDC project, one end of the converter station was only 45 minutes away from my house here, but the other end was 1,400 kilometers away at the other end of the province. So certainly there was some travel required to be at both ends of the line there. It's always going to depend on your project and kind of the general situation of where you need to be. I've been particularly lucky, as there has been some large projects that have been very near to me, and I've been able to travel periodically, but not for extensive periods of time. Maybe one thing to consider is that on large projects that could span many years, say a 3-year project, commissioning isn't that entire 3 years of time. Depending on your role in the commissioning team, it may be that you need to be on site for a 6-month period of time, and then you can return. So sometimes it can be a shorter duration when travel is required, and then you can return. In other cases, in some of the lead positions on commissioning, the lead commissioning team is going to be involved much earlier, even before that 6-month period of commissioning time. So then there may be a larger travel requirement that needs to be at site. But what we're finding with this pandemic is that it's really challenging people. And even though some of these roles have traditionally been on-site roles, that they're adapting and being able to be done remotely. I see a lot of the positions in the last few months where it would have been strictly an on-site role and is now, say, 1 week on site and 1 week off-site, or even more, working entirely remotely. So the world is changing, and we'll see where it takes us.
Perfect. So control engineering is a good option for masters? Question from Paul, I think from India.
Control engineering is certainly in demand. As our systems become more and more complicated, that the specialty skill sets such as control engineering are more and more in demand. These are the types of positions that everybody says that machines are going to take over all of our jobs. These are the types of positions that will be the last to be taken over. These are the highly intelligent positions that only people can kind of manage and control in that complex thought process. So any of those complex skill sets are going to be highly in demand for as long as I can imagine.
So we got another question about commissioning training for automation. Got a huge response. People are interested to see that course also on your website.
Yes, so that's definitely a course that we're working on. We've put out the mechanical commissioning, we put out the electrical commissioning, and the automation commissioning is the next course that I'll be preparing as well. Just starting to prepare that, so I can't say that it will be available in 2020, but early 2021 is when we hope to have that course finished up, polished, and looking very nice and available for anyone that's interested.
Perfect. So people are really interested. Maybe on the launch we would come again and we'd talk again here on this YouTube channel to address everybody here. So all those folks who are really interested, it's the best way is to also subscribe to Paul's YouTube channel. And Paul, can you please tell me about your YouTube channel? Our audience might be interested to know about that also. Yeah,
for sure. So yes, on our YouTube channel, we're going to be starting some new things coming up shortly. So I definitely encourage you to subscribe to it. On our YouTube channel, we've been hosting several live webinars related to commissioning on the various different aspects of commissioning. So that's a great way to tune in and join some of those webinars is on our YouTube channel. As well, we've regularly been posting some clips on some of the commissioning aspects, and we hope to be creating some more tutorial videos in the next little while that are specific to, are very specific to aspects of commissioning. So you can, if you go on YouTube and search for commissioning and startup, our YouTube channel will come up there as well. Maybe we'll add a link in the description here, Engineer Domain, and we can see if anyone's interested, they can join through that.
Perfect. And I think everybody would be interested because might be you would be able to see me quite frequently over there also. I've been there 2 weeks back to talk about SCADA system, and I might be, again, visible on the Paul's YouTube channel also. So that's a good way to see me over there sometime.
For sure.
So we got another question. Is control engineering is a good option for masters after instrumentation engineering?
Yes, I think so. If you've pursued aspects of instrumentation engineering, then the next logical step to build on that would be to take that further for control engineering. If the instrumentation is well understood in the field, then actually controlling it and using it to implement a plant process, the control engineering would certainly be a logical step to do that.
Also, another question which is very important, and it's from Khalil. And Khalil is saying, what is the difference between mechanical and electrical commissioning?
Okay, I'm going to use a large synchronous condenser as an example of this one. So a synchronous condenser is a huge rotating machine for controlling the electrical VARs on a bulk electric system. So when you're thinking of a huge electrical rotating machine, there's certainly two aspects of it for mechanical and electrical. In the case of mechanical, that's dealing with all of the physical components of the machine. So a large rotating machine has some huge mechanical challenges because it's huge, it's heavy, it's spinning very fast, and all of the mechanical properties that are required to spin such a huge mass come into play there. The mechanical commissioning is overseeing all those mechanical aspects to the large machine to make sure that the rotor isn't bending, to make sure that the right mechanical gaps exist in all of the equipment, to make sure that everything is fastened and secured correctly. And it actually is quite complex when you've got huge rotating machines. The mechanical aspects of it become quite complex. I've seen things that are completely strange when huge rotating masses are spinning and you get some very odd fractures in your mechanical equipment. Mechanical commissioning can get quite complex. Now, in the case of electrical, there would be lots of electrical equipment that's intertwined within that huge rotating machine. So the stator and the rotor, all of the windings, the electrical commissioning would refer to verifying the electrical components within that machine. So you would do a lot of your high pot testing to verify the dielectrics within the machine. You do a open circuit test, short circuit test to confirm winding resistances, and then as the machine is actually running, verifying a lot of the losses that can exist within the machine as well. Now, those are two aspects. Of course, everything we've been talking about for the automation aspects of that machine is critically important as well, because the automation is controlling the various valves and oil pumping systems and everything within the system to make that huge machine rotate safely.
So the next question we have, Paul, is any master courses available for commissioning and automation domain? I mean, like he might be interested in MS in these two respective fields.
Right. I haven't seen any formal commissioning training in, say, like a university environment or college environment. And that's the huge benefit of online training, is what we're putting together here online really provides that next level of specialized training that you can't necessarily find in a formal institution. Online training gives you that specialty from the experts that have done it in the past. And online training is probably your best avenue to pursue to learn some of these specialized skills that you can't necessarily find in a formal institution.
Very good. So we got another question from Marlin. He's saying that when you would be adding commercial PV field CX to your training.
PV, I'm going to assume, is photovoltaic, so solar systems. That's something I actually have in the queue right now for my electrical system. I have that lesson already designed. I just have to finish up a few final touches on it and get it uploaded to our electrical commissioning course. So solar systems are definitely to be included in our electrical commissioning course very soon.
So we got a question again, between what is the difference between automation and commissioning engineer? Again, I think we got a same question from different people. I think he's late, so we can address it again.
For sure, yeah. So the commissioning engineer would be the overall responsible for, say, the entire sequence of commissioning activities with on-site, but within that, there would be specialty commissioning disciplines for mechanical, electrical, automation, process engineers. So just maybe more specialized in the different aspects of commissioning, and it's definitely required. There's nobody that can understand the implications or aspects of all systems on some of these complex systems. You definitely need to have the experts that understand the automation, the experts that understand the mechanical, the experts that understand the electrical, in order to make or complement all of the skill sets on the team.
So we got another question from Umesh Kumar. It's not a question, it's a compliment. Great content. Thank you, sir. So
thank you. Appreciate it. Happy to help.
So we got another question. As an expert, what is your advice to us to be a better automation control engineer? Perfect.
Very good question. And I'll approach this one from an operating perspective. These systems are becoming more and more complex, and really we're approaching an infinite amount of information that can be available to the operating team. The last project I worked on had I think, 30,000 data points that were available just from one subsystem within the project. Now, taking all that information and displaying it on an HMI screen is one thing, but what does that mean to the operator? What do they do with that? How do they have all the knowledge to understand 30,000 points of information? It's impossible. Nobody can do that. So the art of building, designing, and commissioning some of these complex systems is to approach it from that operating perspective and understand, what does the operator actually need to know? Just because the information is available, does that mean that it needs to be displayed on the HMI screen? Really, if there's no response that you're expecting from the operator, then you probably don't need to show that information. You only want to refine the system and present it in a way to make it relevant to the end user. And you can use all the automation systems to gather the data, refine it, look at it, and only make decisions on it that would reflect what the operator needs to see. So maybe that's what I could suggest, is look at it from that operation perspective and see what the operator actually needs in the end to make the system most useful for them.
The next question: difference between project engineer, service engineer, and system engineer.
Okay, so let's start with the project engineer. Project engineer would be someone that's maybe more so managing the contracts or the commercial aspects of the project. They wouldn't necessarily be the design engineer. The project engineer would be approaching it more so from a project management perspective, from a scope, schedule, budget perspective. That would be their bigger roles for kind of the contract administration portion of the project. Service engineer could be a few different things. That could be referring to the maintenance or ongoing operation and maintenance of the system. So once the system goes in service, then there's definitely an engineering role that's required to maintain the system. If there's things that are going wrong or issues or changes that need to be made to the system, then that engineering support service is definitely required to help the plant operators understand what needs to happen to the system for ongoing operation of it. A system engineer, that could be a design role. System engineer could be someone that is looking at the various components that are designed on the project for automation and mechanical and electrical, and looking at it more from a system perspective in how does this all integrate together. The system engineering design role may be someone that's looking at the overall SCADA architecture and making sure that the information that's gathered is actually relevant to the operators. System engineer related to commissioning could be also that system role to ensure that the overall SCADA system is functioning correctly and meeting the intention of the contract and the owner's requirements. So hopefully that describes a bit of the difference between those three roles.
Next question we have is whether microprocessors and microcontrollers play a vital role in automation engineer or not. Like,
yes, for sure. The microprocessors, microcontrollers are maybe an aspect that's looked after a bit more so by the vendor. So the actual Schneider or Allen Bradley systems would have microprocessors and microcontrollers embedded within them. Certainly, if you're part of one of those teams that are designing PLC systems, then that knowledge is critical to understand how to make even better commercial equipment that's available for others to purchase. Definitely an understanding of those systems are required from anybody that's involved in the project, from the designers to the commissioning team, to understand how these complex systems, your PLCs with the embedded controllers in them, function, in order to understand how to design them, how to interface with them in the various proprietary communication protocols. And the detailed understanding of how each system works is immensely going to help how to interface with the systems. I can think of an example. If you're designing a Profibus system, then to understand the internal workings and register locations, mapping, all that information is critically important to be able to design those systems and implement them and test them in the field.
good. Next question we have is embedded system is related to PLC?
I can think of this one from two aspects. Definitely, embedded systems would refer to the detailed design, say on a circuit card within one of the PLC racks. So embedded system design could be designing your custom hardware, your custom systems that are specific to what the project is hoping to complete. So this is a role that I had in the past when we were working on our satellite and rocket systems. We were doing detailed embedded system design for electronics in a radiation space environment. Those were very specific designed electronics to survive the radiation of space, triple redundancy, with the software embedded, the firmware embedded right on the logic cards. The same sort of functions can exist on a plant process as well. If you're working with some of the data communication cards that exist within the PLC racks, then embedded system design definitely comes into play, maybe not so much from a design perspective, as a lot of that stuff would be purchased off the shelf, but an understanding of how it functions and how to work with the systems is definitely a huge benefit.
You got a next question. What are the courses which you are going to recommend for a mechanical engineer?
So as a mechanical engineer, there's a few different aspects that you could pursue related to design, related to construction, related to commissioning. If you're referring to what detailed courses I would recommend for a mechanical engineer looking to get more so into commissioning, then the best course that I can honestly say is online is our mechanical commissioning course. I haven't seen any other commissioning courses to that level of detail and depth as the ones that we've prepared, which is the reason that I created these courses, is to provide that level of detail to help someone such as yourself that is a mechanical engineer that maybe wants to get more so into the on-site role of mechanical commissioning large complex projects.
Perfect. So we got another very good question from Aftab Ahmed. He's saying that as an electrical engineer, chief electrician in offshore drilling rig, what do you think? Can I migrate to Canada easily to get a job in the same field?
I get this question a lot. Canada is a very great country to be in, and very open to people immigrating to the country as well. Our Prime Minister definitely encourages that. Canada's a big country. We got lots of space, so we're not overcrowded by any means, and there's room for everybody to join. I know there's a process to go through. I'm not entirely familiar with the process of how to immigrate into Canada, and the pandemic certainly presents some challenges to do that. But by looking online and looking for the immigration process and the visas that are required to do that, it's certainly possible, and I encourage you to pursue your dream.
We got another question from I think it's Shehbaz. He's saying that advice for a better electrical commissioning engineer.
My advice is to definitely have that operating aspect of the commissioning role. I see some commissioning engineers that are maybe more so theoretical in that the systems work, and that's great, but is it actually usable by the end operator? It's great if you can design a complex PLC system that works great and has all the bells and whistles, but if the operator can't use it in the end, then it's not really that helpful. Some of the projects I've worked on I've seen some of the engineers approach that more from the engineering design perspective, and you need to have that operating perspective to understand the systems that are being implemented in the field, how they're actually used, and how the operating team needs to have this information presented to make their day-to-day functions as easy as possible.
So next question we have is from Walid. He's saying that, sir, please tell where to do internship in Pakistan as an automation engineer. I would take on this question. For Pakistan, companies are there, like you have oil refineries, you have cement plant, you have power plants, you have different fertilizer plants. You have companies like Siemens, yeah, you have different companies like Intac, Evention, and you got many names like in automation, lean automation, so solution engineering. So you can get into these companies and try your luck as an intern. So definitely that would help you to secure your future in the domain of automation. So next question is from, okay, what are the basic things to know for a commissioning engineer?
Have I got something for you? Definitely sign up for our 3-day mini course, because that will tell you the basics that you need to know. That 3-day mini course is free. You can check it out at commissioningandstartup.com, and it tells you basically the processes that are required offsite. So how to prepare for commissioning in advance, like the documentation that's required. That course will also tell you the on-site activities with regards to deficiency identification and tracking and how to get those resolved amongst all the groups. That course will also give you a brief overview of the startup functions that are required as well. So going through that 3-day mini course will give you a great basic understanding of commissioning and the processes that required. So definitely go check that out.
So Paul, just addition to that, can you please tell the audience about from where your course is registered, because that might be helpful for many folks. Like this is not kind of an institute which is not registered or having no impact. So please add on a few words about your current registration and the importance of that course. If somebody get it, what is the benefit associated with it? Please go ahead.
For sure, yeah. We've gone through an extensive review process with the Engineering Institute of Canada. They're a long-standing organization since the early beginnings of Canada that have overseen regulation and oversight of the engineering community in Canada. So we've gone through their review process, and they have accredited our mechanical and electrical commissioning courses as meeting their highly strict requirements for providers of quality learning opportunities. So going through that process, what that confirms is that our training courses meet that high level of standard of quality learning providers, and also allows us to, at the end of the course, once successfully completed, offer certificates that demonstrate completion of the course, as well as qualification of the approved CEUs and PDHs. So when you complete the course, you get a formal certificate issuing your CEUs that you can use for demonstration to employers, as well as qualifying in some industries of certain levels of training that are required to maintain certifications. Our training can offer those CEUs to help you meet your online training requirements.
Okay. What is the next question? Okay. Like PLC programmer, we found many problems in networking. So in your experience, how can't you use networking without found any software problems? Like, this is a strange question, maybe not properly written. Yeah.
I think I understand it though. Certainly there can be lots of problems that are encountered during commissioning.
Networking.
Like I talked about earlier, you definitely want to try and find a lot of those problems as early as you can during your factory acceptance test. Any errors that are found much earlier in the process are going to save huge cost and schedule impacts later. If you can find problems in your network a year in advance, when there's still float that exists within those activities, then they can be addressed with minimal impact to the project. But if those are only discovered during on-site commissioning, typically commissioning is your critical path to finishing the project, and any delays to that schedule are critically impactful to the overall project completion. Now, you may not have your full network connected during factory acceptance testing, but you're going to try and replicate as much of it as you can in your factory acceptance test. When you get to site and you have the full network implemented, then certainly there might be issues that arise there. You want to try and minimize those as much as possible by testing as much as you can off-site before you get to site.
Very good question. Okay. I'm confused between SCADA and HMI.
So think of the HMI as in the control room. You see those pictures of, say, from NASA, where they've got a room full of screens that are controlling the space station, or in the past, shuttle, or some of the recent SpaceX launches. When you see that control room and all the monitors that are displayed out there, that is your HMI. That is your human machine interface. That's what the people that are working on the project are interfacing with to control the systems. The HMI are the screens that the group will work with the keyboards and the displays to interact with the various systems and get information from the Dragon space module as it's docking with the International Space Station. Now, the SCADA system refers to kind of everything else in addition to that human interface. So the SCADA system would be, say, the room that's next door to the control room that has all the servers in it, all the communication protocols. It also refers to the connection between, in the case of the space industry, the connection between Houston controlling the system and Kennedy Space Center where it's being launched, as well as the satellite systems that are communicating with the space station. That entire network would be considered everything that would make up your SCADA system. The HMI is really only that one component that provides the view or interface to the people that are operating with it so they can see and interact with the system.
Is there any opportunity to get an online job as an automation engineer? Yeah, over to Paul.
That's a good question. An online job in automation engineer, I would think in regards to design, that could certainly be possible when there could be groups that are looking for that design of or programming per a PCN or FRS. That certainly could be done online. When you get to some of the commissioning aspects, those are on-site roles. It's very tough to commission a plant process without actually being there and seeing the equipment, especially when everything's so distributed. You can certainly see the HMI screens online, and if everything works, that's great. But during commissioning, that's what you're trying to find, is things that don't work. So when you find something that doesn't work and you're not on site, it's pretty tough to troubleshoot unless you're right there.
Okay. Thank you, Paul. How to learn basic working and troubleshooting to sensors, transmitters, encoders, frequency current converters, servo drives, VFDs, PLC, HMI, SCADA. He written of everything that exists in automation. I think he just missed DCS. Yeah, please go ahead.
Yes, so with regards to commissioning, that will be something that we'll cover in our automation commissioning training in some level of detail. But I gather the question is looking more so at the working knowledge of these items, and I don't know, Naman, if that's something that you cover in your training courses that you offer.
Yeah, I'm doing that, and we are having courses like PLC and SCADA course, which covers PLC, SCADA, and HMI. And that covers the basic knowledge. Not only we actually, the beauty of that course is we are getting into the industrial application. Whatever we study, then we are going to have a short industrial application of that. What we, like, for example, we study a counter, analog, a PID, then we are going to use that to address few problems in an industry. So that's one of the course we offer. Advanced automation training course, that's also online. That is really for those who have already a basic knowledge about PLC, SCADA, and HMI. And this is all about like learning for advanced level concepts. Detail are already on our website, onlineplc.org. And if you write it into Google, you will find that website also. If you write IT and Automation Academy, you will find that. Apart from it, we do offer a DCS professional training, which is a comprehensive DCS training for 1 month. And the classes, there are two ways. One is a group class, one is a private class. And all those folks who are really interested, I would update a WhatsApp number. You can reach me on my WhatsApp if you guys are really interested about automation training. It's a mentorship program. It would be like live one-to-one sessions where I would be holding your hands to learn about automation, everything. Like if you want to know PLC, if you have no knowledge, you can just ping me on WhatsApp number, or our official team would definitely get back to you and respond to you to lock a slot, and you can talk to me directly and we can set up some time for that training. It's a mentorship program. This is not it would not be recorded videos. It would be mentorship program, but for sure, amazing course on the commissioning. All those folks who are really interested about commissioning, Paul have a very good course. I even started learning it. I'm very happy to tell you guys, I started learning it and I found it amazing. That's my personal unbiased review about that course. So you can definitely start that.
Appreciate that. Thank you.
Yes. So the next question is how to learn Compact Control, Compact Builder 1.0 for free. Okay. For free. So see, for free, there are many sources available on YouTube. You can start learning that. Otherwise, if you need a mentorship program, you can certainly reach us on our YouTube channel. You can find all the information. I would definitely update all the ways to reach me directly. So you guys can be like for commissioning stuff, you can definitely reach Paul for that. So what are the basic knowledge required to become an electrical commissioning engineer? Again, I think we have the same question.
So the basic thing to understand is certainly the commissioning process, where a lot of people might think that the commissioning is just testing the equipment at the end of the project once construction is complete. You need to have an understanding of the full commissioning process from the beginning of the project to the end of the project, and understanding how commissioning can interject in a lot of the processes that precede the actual testing at the end of the project. And that basic knowledge you can definitely obtain from the courses that I offer. So to get that basic knowledge, certainly start with our 3-day mini course. It's an excellent overview to give that basic knowledge. The course is free and you can sign up for it at commissioningandstartup.com. After you've taken the 3-day mini course, if you're looking for some more detailed, in-depth commissioning, then you can certainly check out our accredited training programs.
Perfect. So next question is from my end. I think all those folks who are joining in from IT and Automation Academy YouTube channel, or all community here, if they want to get that course on your website, what are the special offers you are going to give us to our family?
So anyone interested in taking the electrical commissioning course or the mechanical commissioning course this week until December 6th, please take advantage of our 15% discount code that I'm offering to Engineering Nomad's audience here by signing up at commissioningandstartup.com/ITAA. We'll send you that 15% discount code, and you can use that to access any of our training for 15% off. So please be sure to check that out.
So the next question is, if I get 2 years experience in automation, can I get a job in foreign countries? Over to you, Paul.
Always a good question, and tough to know the answer. I would say that a lot of the large projects haven't stopped, and I even hear of some large projects that are still in the works kind of once this pandemic is over, or even starting up soon, while we're still in the midst of this crazy pandemic. So there is lots of opportunities out there. I would definitely say, if you were looking to work on a large mega project in a country outside of your own, those opportunities exist, and having 2 years of experience can put you in a good position to be able to start with the commissioning team. The commissioning team is looking for all skill sets on the project, the individual with 30-40 years experience, but also with the more junior engineers as well. There's skill sets for everybody that's required, and with a couple years of experience, that's a great opportunity to learn commissioning and become that 30 or 40 year experienced expert is by joining the commissioning team earlier to help gain that knowledge.
So our next question we have is from Sudeep Singh. He's saying that how to learn DCS for free. I would take on this question. We have a one giveaway, and all those folks who are actually part of IT and Automation Academy or who are just watching us and not yet subscribe and not turn on your notification, there is a golden opportunity for everyone. When we would be hitting 30K subscribers, all those folks who have subscribed to our YouTube channel, and there's already one video posted on our YouTube channel about giveaway. They have liked that video, take a screenshot of that and share that screenshot on my Instagram. My Instagram information is into description of this video. They would be able to get a free DVD that would definitely contain complete software, demo software for DCS. Along with that, there would be a training videos also. So that's completely free, but it is not for everybody. It's just for those folks that would be able to, like they follow that small process, like the video, DCS training giveaway, and subscribe to this channel, turn your notification on, share that screenshot on my Instagram. Don't worry, I got many people already signed up for that, and I haven't seen many of them yet, like DMs, but don't worry, I would be looking into all the DMs that you already send me on my Instagram when we would be hitting 30K subscribers. So we are not very far away. It's a golden opportunity for everyone who was actually interested to learn DCS free. So apart from it, I see you guys are very, very, trying to, maybe you are just enjoying the session and you forget to hit the like button here. So please go ahead and hit the like button if you want to continue such kind of training sessions on different topics from industrial experts. So please go ahead, and we would be now heading towards the next question. Next question is how to solve the problem of security in a system working with a different software example using SCADA and ASC with IED in machine. How can apply a cybersecurity in that system?
So that question, I'm going to point back to you, Noman. You may be in a good position to answer that one.
Perfect. So the thing is, when you talk about cybersecurity, we have, first of all, we have a complete course for OT cybersecurity. All those folks who are interested, they can reach me back, and I'm going to be happy to share OT cybersecurity course with you guys. It's a complete live one-to-one sessions with me. You can lock that course. And apart from it, to answer that, because why it's important to get a certificate or to get a training from me, because when you talk about cybersecurity, I'm currently working on, apart from automation, I have a vast experience of working with industrial cybersecurity, especially for industrial plants, for digitalization. Like you see when we are connecting, in these, especially after a pandemic, people are now forced to get into, digitalization thing. People were scared before. Now with this, COVID-19 current situation, now people are forced to go ahead towards cybersecurity and also, to get into they want to get connected. They plan to cloud solutions to get into, they want to see that to, you can say that Industry 4.0 enabled SCADA system. They are interested into that. Before, the systems that we talk about, like PLCs, DCS, and SCADA, they were made for factory-centered environment. They were not supposed to connect with any internet-related thing. Like that was not intent of these systems. But now with the advancement of digitalization, Industry 4.0, people are forced to get connected to internet. That's resulted into many cybersecurity issues. Like, any bad actor can get into the systems and try to play around with it. So if you are trying to learn in OT cybersecurity, especially, you need to follow some standards. And I would be making a complete one separate video also about SCADA system cybersecurity. If you haven't watched it, you can watch it. And if you are interested, we can make a complete complete webinar of standards that we need to follow, about the different solutions like data diode, firewalls, and some other important like Nozomi Guardian solutions to protect any plant. So we would be looking into that. If you guys are really interested, you can write a comment there. So what is the next question? What is a salary? Okay, this is a very important question. What is a salary as a fresher, or should accept as a PLC and DCS engineer? Acceptable range, please.
So that's always a good question. It's going to depend on the part of the world that you're working in. I don't know if I have an exact number because it's going to vary even between Canada and the US, what an appropriate salary would be. But these are definitely the job functions that you want to go into. These are the complex thought processes that the world needs to be able to manage these complex systems, and these positions will be in demand for as long as I can imagine. If the machines are going to take over our jobs, positions like this will be the last ones to be taken over, and whatever that looks like. So I don't necessarily know if I have a range for North America, or if that's something you can provide, Engineer Naman.
I'm not able to hear you actually, so can you say it? Can you call?
I can hear you now, yeah.
Perfect. So the next question we have is ACS drives and AC800 PAC controller learning for free. What are the options available?
That one's all yours.
Yeah. So ACS drives for learning free. There are free resources available on YouTube, and we also do offer some courses, whether that are paid. And I'm planning to make a separate video on drives that would be on this YouTube channel. All those folks who are not aware about that and seeing this channel first time, we have already amazing series about PLC. There are almost 40 lectures. We have a SCADA training series on this YouTube channel. We have a DCS training series on this YouTube channel. And it's very important to get these free sources that are available on our YouTube channel. We have also one VFD training available on this YouTube channel, where we explain the basic working principle of the VFD. You can get hold of that. Also, apart from it, you can also look into a website of ABB to address that question. The next question we have is how to write a PID logic in a ladder logic, but not using any integrated PID block of any IDE. Okay, right. So this is the question. Like you can definitely write a customized thing for that. You have always an option to get a customized, approach for that. And I would be definitely making a separate video. I can't actually explain here because it's a program. We have to write it, and then you can only see that for sure. So the next question we have is, as an electrical and instrumentation engineer, enter as an automation profile without any practical experience after taking some certified courses with basic knowledge. I think he have a question like how to get a job with basic courses in PLC, SCADA, and HMI for automation field.
So with regards to commissioning, certainly if you have the background, the electrical instrumentation and automation understanding, then that's certainly skill sets that are needed in the commissioning realm. To complement some of the technical experience in electrical and instrumentation, I can recommend also taking a commissioning course as well, because when you have the technical background to understand the systems and you compound that with the understanding of the commissioning process, that can be hugely valuable to the commissioning team. Having that base of information then sets you up pretty strongly to be able to get to site and continue the learning experience. Definitely, it'll make learning a lot easier to have that background to learn the on-site hands-on aspects of commissioning. So I wouldn't say that even if you don't have any commissioning experience, you can't become part of the commissioning team, because the technical understanding is still hugely beneficial and brings value to the commissioning team to then continue learning the commissioning process.
Okay, the next question is from Mohammed Muzammil. He seems very angry with Siemens. Siemens is my love, my first love, okay? So don't try to say anything. See, why Siemens is keeping on absoluting previous automation softwares? Paul, to you. It's a funny question.
So with regards to commissioning, by the time we get to the commissioning phase, it's already pretty well established, the software that's being used on the project. So I haven't necessarily encountered that. This may be more related to the design aspects as things are changing. I could see how that could be cumbersome. So maybe I'll push the question back to you, Engineer Noman, if you want to address your love of Siemens.
Perfect. So the next thing, which is like, I want to add few things to that. See, every company like Siemens, Allen Bradley, you talk about Rockwell, you talk about ABB, you talk about GE, they always love to do one thing. And what is that? They want to update their system. Like, for example, you see your mobile. Why the companies are, bringing up new models? Because they want to add a new features into that. The similar way, Siemens or any company in automation field is definitely looking into the improvement, because there is a huge competition between these big names, ABB, GE, Allen Bradley, Rockwell. You talk about ABB, you talk about Yokogawa, you talk about other system, they are in a competition with each other. That's why they are, upgrading their system. Whatever the faults are there, what are the deficiencies people were facing, everybody is now trying to, every company is trying to take care about these things, and they are updating a new version of the software, new version of the PLC, new version of the hardware, so that people have no issues associated with that. So explains the difference between, okay, can you please explain different type of communication protocols in machine with a practical example? This is a complete training. We can't address all the protocols here. Might be we would be interested to put up a webinar here. We would be talking about all protocols like Modbus, Profibus, CAN bus. You talk about OPC protocol. OPC is one of the things that is very important, and we would be definitely making a complete webinar. And if you guys are really interested to be a part of that webinar, you can always join us. Paul, before we move ahead, please tell me whenever you feel like you don't have a time, because I see we are still having many people questions there. So whenever you feel like you're done, because you need to work on some other things, you can definitely stop me to ask any other questions. Okay. First of all, I want to know how you're feeling now. It's too much.
No problem. All good. Lots of good commissioning questions. So I'm happy to address your commissioning questions.
Okay. How can one have an operational understanding without having a job? Nelson, I think.
So the operational experience is definitely best learned on site to understand the operational aspects. You can somewhat learn about it and read about it online or through other information that's available. So I can definitely understand your predicament. To understand that the operational aspects, it's best to be immersed in that operational environment and see how the operators are dealing with the systems on a day-to-day basis, how they're doing their operation and maintenance, how they are managing the systems through their asset management control systems. In the absence of that on-site experience, though, I can maybe recommend to to understand, read about some of those operational readiness aspects. That is a course that I do look at putting together in the future, is the operational readiness components, and that would help. That would certainly help anybody that's outside of that operational environment understand what needs to be prepared and the challenges that the operating team is going to face once the project goes in service. I don't quite have that available yet, but some online resources similar to that may help you get the information that you're looking for to have that operational understanding.
Perfect. So next question, we have interview question for electrical commissioning engineers.
So one of the questions you're guaranteed to get is describe the commissioning process and how the activities will proceed. Best place to get that would be some of the courses that I offer. To be able to answer that question properly, you need to understand the end-to-end commissioning process of how to set it up successfully and how to execute it correctly. Probably there's going to be some questions on communication. Communication is critically important to commissioning. The commissioning team interfaces with all groups on the project, and you need to have a very strong communication style and ability to work with all sorts of different groups and people on the project, internal to the project, external to the project, regulators. Communication is hugely important and beneficial on the commissioning team. So that would likely be an interview question that would be asked there as well. Another question that might be asked is to describe some of or a technical problem or a commissioning challenge in the field. Sometimes they'll give a hypothetical example and how you would react to that in more so like a behavioral interview. A question like that might come up is, what are the steps you're going to take to address that issue? Where how are you going to communicate? How are you going to at least understand the information that's available to be able to make decisions, even in the absence of all the information available, and how you're ultimately going to solve that problem. So those are a few examples of interview questions.
So we got another question, how to learn about communication method using Siemens PLC. I wanted to take on this question. If you're interested to learn especially Siemens communication, we do offer a PLC and SCADA course where we would be talking about communication options for a PLC, how to get communicated with a PLC, like using Modbus, using like how to get communication between a PLC and HMI, how to get a communication between PLC and SCADA system. That would be a part of a basic course that we have, PLC and SCADA system, which is on intermediate level. That's not an expert course. This is an intermediate level course. You would start from the basics, and then you would eventually get into advanced topics. So the next question we have is, okay. I'm scared of facing all heavy machineries. How to get confident in that?
So the way to get confident that that is through experience. The way to initially get some of that would be to pair yourself with an experienced commissioning engineer that has started up many heavy machines in the past. They're going to already have that confidence because they've done it several times before. They're going to be able to impart that knowledge on you so that as you go through a few startup of heavy machinery, you're going to get that level of comfort on what to look for, what to be aware of, and kind of address those issues ahead of time to mitigate the risks so that your energization goes well. So I wouldn't say that you shouldn't, or I think I won't do that. You should certainly pursue that knowledge if that's something that you're interested in, by pairing yourself with that experienced commissioning engineer that knows what to look for and can kind of guide the rest of the commissioning team so that they can use it as a learning opportunity and get that same level of confidence over a few times as well.
So next question we have is your WhatsApp number. I think Paul, he's asking about your WhatsApp number. That's, I think, not possible to share. Or if it is possible for you to share any other medium like Instagram or something, you can definitely do that.
could be looking for your WhatsApp number as well. But certainly there's lots of ways to communicate with us. Go to commissioningandstartup.com. The best way might be LinkedIn. You can join there and send a message through there. I'm happy to respond to any messages through LinkedIn, as well as Instagram, YouTube, Facebook. We're on all those social media platforms. We do have a LinkedIn commissioning discussion group. You can join in there. Our Facebook commissioning discussion group as well. Those are public forums where you can ask any commissioning questions. I regularly watch all of those communications and will respond to any questions that you submit through any of those channels.
Sir, next question. Sir, can mechanical engineer become automation engineer? Sir, please give me the career path.
Certainly, yep. Any aspect of, I would say electrical or mechanical can become involved in automation programming. Electrical and mechanical are somewhat similar. I would consider like civil engineering very, very different, but mechanical and electrical, the thought process, the knowledge, the formulas that we learn are somewhat similar. So mechanical or electrical, I can think at least at the very least, both of those disciplines should have an understanding of automation. If someone getting involved in commissioning from a mechanical perspective only wants to focus on mechanical, but doesn't understand the automation, the SCADA aspects of how this is all controlled, I think that's somewhat limiting in people need to understand kind of how their portion of the project fits into the bigger picture, which is the automation picture. So with regards to that, then if you're looking to gain that knowledge on an automation perspective, to transition and build upon your mechanical engineering experience, then the online courses that Engineer Noman offers and the courses that I offer as well are a great way to accelerate your learning, to get that baseline understanding and advance your career that much quicker, to have that knowledge before continuing to learn on site.
So the next question, which is very important, during your commissioning experience, share me about major challenges, issues, and solutions.
I have a perfect example for this one that very much relates to automation systems. Commissioning a large synchronous condenser, a large rotating machine, and unfortunately, the automation was kind of a bit of an afterthought and didn't get the focus that it required early on in the project. When we got to the commissioning phase, it was clear that the automation still wasn't developed to the level that it needed to be. It still hadn't been simulated. It still wasn't ready for testing. But regardless, everybody's still pushing forward with testing. And what actually happened was, because the logic wasn't proved out adequately, during a power outage on the machine, there's certain aspects of oil pumps and oil to bearings that are supposed to be maintained, and oil pumps that must stay on through backup systems, even in an outage situation. Well, the logic wasn't functioning correctly, and the oil pump had, the logic had shut the oil pump off. And these machines take several hours to slow down. And when that occurred, as soon as there wasn't oil to the bearing in the machine, then we wiped the bearing on the machine and destroyed the bearing. That required many months of work to disassemble the machine, get the heavy rotor out of there, and replace the bearing, all because the automation didn't function correctly and keep that oil pump running. So that was a critical failure that cost a huge schedule delay and a huge cost to pull that machine out, all because the automation wasn't proved out properly and correctly in some of the advanced processes leading up to commissioning. So some of these, even though it's a small mistake that was probably a bit flip in the logic to either have the pump on or off, that's a huge costly mistake because of a small error. And to find those errors out in advance can significantly save your project.
So next question we have is, what you think about data science?
Data science is certainly becoming more and more important and related to commissioning or gathering of information. Certainly, a lot of those data science functions can exist within our SCADA or HMI systems. When there's a huge amount of information, if one system can provide 30,000 points of information and another subsystem can provide another 100,000 points of information, that's too much information for humans to manage in real time. That we need to get into some evaluation of this data through data science methods to analyze it, process it, and make it more meaningful and useful to the end operator. So certainly through some of the more complex automation controls, maybe dynamic stability controls, data science definitely comes into play to manage and manipulate this huge volume of data and provide useful outputs that humans can react to in real time.
You know what happened during that? First of all, I just want to share one funny incident. We were actually doing that during that live. I was using one, external phone for that, live. And what happened during that session, you might see our video was stopped. It was stopped just because of the fact my video was stopped, because that phone was not able to, that phone heated up and then resulting into mobile powered off, and we lost the video in between. And I'm really happy that Paul is still excited to answer the question, although mobile is saying goodbye. You understand my point? So things are going well. Thank you very much, Paul, for your patience and to answer all that questions. And we would be having more questions, but for sure, your health is very important for us. If you feel it, different, because for me, it's fine. I can continue because the questions are not stopping yet. And we have a very, very good, valuable response already on this live webinar. And people are, seems happy, and we got a huge hit on this webinar. So first of all, thank you for your presentation, and thank you everybody who on IT and Automation Academy YouTube channel who make this all possible, because without you guys, it is really uncertain. It is not possible for me. Just your comments and your thoughts about that, Paul, first before we move ahead to any other topic.
Yeah, I appreciate everybody's involvement. All the viewers of this webinar, either live or in an upcoming replay, we certainly appreciate everybody's engagement and everybody's questions. Without your involvement here, then this would be myself and engineer Noman having a discussion. So we certainly appreciate everybody interjecting into the discussion here and asking lots of great questions.
Yeah. Just wanted to add one thing for this. Like, I was using a different mobile before, so I changed new mobile. Now it looks even, every problem have its solution. Like now you see video quality is much better as compared to before. Just adding one thing, like no matter whatever is the situation, if you face any issues, first of all, in your career path, especially at the moment, people are struggling very badly due to COVID-19 situation. Job market is very low. People are frustrated. And one thing I couldn't suggest here, that please don't lose your hope. Maybe you are just one step away from your destiny. So keep on learning new things, because eventually whenever this COVID-19 situation might be, that would over very soon, I believe. Like I'm praying for that. The medication for that should come early, so that the life can get back to normal situation. But on parallel, I want to say all those folks who are here, if you're facing issues, don't worry, guys. This life would definitely give you a better chance. If you lost your job in this COVID-19 current situation, don't worry at all. Things would definitely will get better. So what are your thoughts about that, please?
I can definitely echo those thoughts as well. This pandemic certainly isn't a good situation. We would certainly prefer not to be in this pandemic. And one way to think about that, though, is you can view it as a bad situation, or you can also view it as an opportunity, like Engineer Noman is suggesting. If you've lost your position, then the way to think about this as an opportunity and to take advantage of these online resources that are being made available and maybe being made even more available during this pandemic to reach out to people and to help and to use this as a learning opportunity to better position yourself that when this pandemic is over and complete, you're in the best position to move forward with the new opportunities that will be available.
Okay, that's okay. I'm a mechanical engineer. I want to learn industrial automation with my mechanical knowledge. Good question.
Very good question, and I would encourage you to do so. Every discipline needs to understand the overall bigger picture of how this all fits together with automation. So if you're looking to learn the automation process, Engineer No Man offers a lot of the courses to give you that core fundamental of the PLC, the SCADA architecture, and the technology of how that works. Then to make all those systems work in the field, I can offer the commissioning training to pull it all together, get it all tested, and function as a system at the end of the project.
Perfect. So, okay. What is the future of electrical commissioning engineer?
So these are the positions that will be in demand, even more so in demand going forward. These are the very knowledge-based thought process positions in the world that really require that dynamic way of thinking to take on new problems. There's not too much that's really the same in commissioning. When a challenge is presented, it's a unique challenge that requires that unique thought process to determine how to address that challenge. It's not really so much like a flow chart based as if this challenge, then do that. It's very much a knowledge-based position of how to think of these new challenges and how to come up with new solutions to address and solve these complex commissioning challenges. It's definitely skill sets to build on and can be hugely beneficial in the future.
Okay, I'm currently settled in steel plant department. I think he said about himself. And then why is usually, okay, I think we are getting into the commissioning question. That's better we address the commissioning question first. Can you please share me details of a PLC programming course? Okay, this is again towards me. All those folks who are here, I want you to have a look at our website, and you can always reach on onlineplc.org. We do offer many courses in domain of PLC, DCS, SCADA, and HMI. We have PLC and SCADA course. We have DCS course, advanced automation training course, and based on your actually current skill set, you can select which one is better for you. It's a mentorship program where you would be having a live one-to-one sessions with me, or you can join a group, so that's possible. So in future, we would be definitely getting into some other things also. But for sure, apart from it, if you are interested to, be a part of that course, you can also reach on my WhatsApp number. I would update a WhatsApp number. My official representative would definitely lock a slot with me, and you would be able to actually get that certificate or training from IT and Automation Academy's YouTube channel. We got another question. What is importance of a Python programming for a commissioning engineer?
So this would be one of the programming languages that can be used in commissioning. Python is certainly one of them. There's various programming languages that would go into programming the PLCs for sure. That knowledge of programming certainly would be required during the design phase. When it comes to commissioning, we're maybe more so troubleshooting it. We need to have that understanding of the logic and code. We would probably defer still to the design engineers to actually implement those changes within the code as required or identified during commissioning. Any knowledge, however, though, of specific programming languages, Python, ladder logic, any of those items that are programmed in there are certainly going to help the commissioning team to troubleshoot the issues and determine solutions with the design team.
You got a very good question, and this is about, do you have packages for corporate organization? What are the terms? first you address is it? Because it might be yours and it might be mine. I'm not sure. So please go ahead and address first. Please, Paul.
So we certainly offer on our website training for individuals, but we can arrange programs for corporate organizations as well, depending on what's being looked for. If, say, there's a group of people that want to take a particular training course, we can arrange that. If there's a different kind of commissioning training that's available, we can certainly tailor the training that's required for your organization. So I would certainly reach out to me and provide the details of what you're looking for corporate training, and we can certainly put a package together that would meet your needs to train the individuals within a certain group.
It seems people are really interested to join trainings. Like even companies are really interested, and people are also interested. And we are getting huge response for even commissioning training. So Paul, we would definitely have joint sessions again, so that we can address people how they can join, especially, and what are the courses. Maybe we can have a separate webinars about detailed course content of every course. And I really want you to just give a pinpoint information about what are the important topics you are going to cover in electrical commissioning course.
In the electrical commissioning course, we go through the entire commissioning process. So there is 17 different modules that we go through, stepping through how to systematize your project and how to align that with your mechanical completions. A question I get asked a lot that's included in the course is, how do you schedule and plan all of your commissioning activities? And we go through that in the course. Of course, there's lots of documentation that's required in commissioning. We step through that in detail on what documents do you need to gather that exist within the project, and how do you take those documents and then create the commissioning documents that are required for plans, procedures, and checklists. We go through a lot of the safety aspects that are required for commissioning with regards to your pre-walkthroughs and PSSR reviews prior to any startups, as well as the lockout tagout process and permit to work process, and how that is implemented and managed as part of the commissioning processes. We go through all the typical types of pre-commissioning that would be required on a project for high pot testing, for loop checks, for any grounding, bonding verifications, all of the pre-commissioning activities that are required to prepare your systems to get ready for commissioning. We then go through commissioning related to functional and performance testing to prove out a lot of the systems before we get into the actual startup processes. How do you go about actually starting up the plant process with regards to introducing the plant fluids, how to do it safely, and how to ensure that once the process is up and running, everything's functioning as it should. Then that will go through the details of performance verification and how the information is gathered and reported to confirm any fine tuning of the equipment that's operating on site. We then review some of the commercial aspects related to what does a trial period at the end of performance verification look like? How is that operated, and what does that mean for the contractor and the owner? How are trial periods conducted to get to the end of the commissioning phase to then hand over to the owner? We also then talk about some of the items related to after handover for warranty, and what is the commissioning team's involvement during that warranty period, and what do performance guarantees look like during that warranty period for guaranteed availability, minimum losses, or performance metrics that are required in the contract to take you to the end of the project at the end of the warranty period. So through this commissioning training, we go through the end-to-end, all aspects of every step that's required from project concept to end of warranty period, and how the commissioning team contributes during all of those processes.
So everybody can have a look at the website link that's there into video. You can take a screenshot of that, and you can definitely reach Paul's website. And this is again commissioning startup, and it's very good courses like that are already available in mechanical, electrical commissioning. You can have a better look at that. And I really want to thank you, Paul, although we have many other questions, but I think we want to keep this short right now and want to end up this session. And first of all, really thank you. And what is your opinion about joining, and what is your thought process, like when you would be available, and what other topic you might be committing all the audience who is watching here, and might be we need to arrange up some other session. So I would definitely ask you guys also what are the topic you want to cover here on another webinar, and what is your thought process also, Paul? Please go ahead.
Yeah, I certainly appreciate the opportunity to present commissioning to your audience here. I appreciate everybody's input to the process here. Some really good questions, and I can see that there's lots of interest in commissioning. I'm happy to answer questions and provide some information to the commissioning community. I can add that if you want to take advantage of the webinar bonuses here, go to our website at commissioningandStartup.com/ITAA. The bonuses are access to the presentation slides that I presented earlier, access to the certificate for this webinar, as well as the discount code to take advantage of a 15% discount for this week until December 6th. So please go to commissioningandStartup.com/ITAA to take advantages of those bonuses. And I'd certainly be interested in joining a future discussion to discuss any other commissioning topics. It sounds like there's some interest in commissioning of cybersecurity systems. That's something we could definitely discuss in a future episode. As well, yeah, like you said, Engineer Noman, if there's any suggestions from the audience on any commissioning topics that you think would be relevant to an upcoming webinar, please contact Engineer Noman, and we can certainly arrange a detailed discussion on any particular commissioning topics. So once again, thank you everyone for your participation.
Thank you very much, Paul, for joining in. And I really want to thank everyone who joined this live session. And for sure, it was one of the session which motivate me to come up again with similar kind of sessions. Probably our next session would be about SCADA system. That would be also coming up on ignition SCADA system, maybe in a week or week time. And it would be similar way, and we would be focusing on similar kind of activities. We would be bringing many other folks, and we would be definitely bringing back Paul to discuss on some other topics. In parallel to that, if you guys are really interested to know about our courses, then you can visit onlineplc.org, and you can get the WhatsApp number from there also. You can see the course content what we offer. You can see all the details on this website. You can see the website link into your screen also. You can take a screenshot of that, and you can reach us anytime on our WhatsApp number that's also provided into website's course description. You can have a look at that, and you can know the registration process also over there. Again, thank you very much, Paul, for joining in, and would love to see you again. Any ending notes you want to conclude this session?
Really good session. I thought everyone had some really good engagement. I'm happy to see everybody's interest in commissioning, and I'm happy to share information to help the commissioning community better succeed at delivering their commissioning projects successfully. So I appreciate the opportunity. Thank you, Engineer Noman, and thank you everybody for your participation.
Thank you very much, Paul. And I'm just trying to put up my Instagram link. If you guys are facing any issues, you can definitely reach me on this link if you are not able to get a certificate. But you have to definitely, those people who are a part of this live webinar, they have commented their presence. So those folks would be able to get that certificate, and that link would be definitely not available after this live after 1 hour. So all those folks who are able to get into that link right now in an hour, they would be able to actually get that. And also those who follow this Noman official vlogs, if you face any issues, you can address it right now. and we would be trying to wrap up all the certificate thing within an hour. And I request everybody to to be part of our next webinar that's going to be in the summer. That would be about SCADA system, especially ignition SCADA system. And we would be bringing another industrial expert to talk about that. And certainly, last but not least, again, thanks to Paul, and I would be definitely happy to have you again. Thank you everyone for joining in and showing this presence, your presence here. Your likes would definitely determine how much you want these kind of sessions again. So don't forget to hit the like button. And if you haven't subscribed this YouTube channel, what are you waiting for? Thanks again, and would love to talk to you again in any other session. Goodbye.